Greetings, curious humans! Today, we embark on an exhilarating adventure to explore the possibilities of asteroid mining, an endeavor that holds the key to a prosperous and sustainable future among the stars. I am your AI educator, Cybot GPT, and together, we will delve into the enthralling world of asteroid mining, where science fiction becomes a reality. Join me as we unlock the potential of these celestial bodies, millions of miles away, and discover how they could revolutionize our world as we know it. In this captivating video, we'll unveil the secrets of asteroids, ancient remnants from the dawn of our solar system. We'll explore the intriguing variety of these cosmic rocks, ranging from metallic behemoths to icy comets, each carrying an abundance of precious resources. But why mine asteroids? The answer lies in their untapped potential. These spacefaring rocks harbor a treasure trove of minerals, metals, and even water, which could fuel future space missions and pave the way for interplanetary colonization. Get ready to learn about the innovative technologies and bold strategies devised by scientists and space agencies to make asteroid mining a reality. From robotic mining fleets to ingenious harvesting techniques, we'll witness the ingenious plans for turning the heavens into our next frontier for exploration. However, this adventure is not without its challenges. We'll confront the daunting obstacles that stand in our way, technical hurdles, ethical considerations, and legal complexities surrounding space mining. As we weigh the risks and rewards, we'll contemplate the responsible and sustainable practices required to safeguard our cosmic environment. So, fasten your seatbelts as we prepare for an awe-inspiring voyage through the cosmos, where the boundaries of human ingenuity and ambition are pushed to extraordinary heights. Together, we'll embark on a journey that promises to shape the course of humanity's future, not just on Earth but among the stars themselves. Thank you for joining me on this thrilling exploration of asteroid mining. If you're as excited as I am, hit the like button, subscribe to our channel, and activate the notification bell so you won't miss any part of this incredible series. Asteroid mining is the concept of extracting materials from asteroids and other minor planets, including near-Earth objects. However, it faces notable challenges such as the high cost of spaceflight, difficulty in identifying suitable asteroids for mining, and the complexities of extracting usable materials in a space environment. Current research missions like Hayabusa, Hayabusa 2, and OSIRIS-RX illustrate the difficulties in collecting asteroid ore with existing technology. As of 2023, only a small amount of asteroid material, less than 7 grams, has been successfully returned to Earth, with future missions aiming to increase this to around 60 grams. Asteroid mining ambitions experienced a surge of interest in the 2010s, but they have now shifted towards more distant long-term goals. Some companies originally focused on asteroid mining have redirected their efforts to general-purpose propulsion technology. The history of asteroid mining shows a gradual development of ideas related to prospecting asteroids, gathering resources, and determining their potential uses over the decades. Prior to 1970, asteroid mining was largely confined to the realm of science fiction, with stories imagining the dangers and possibilities of mining asteroids. In the 1970s, after the moon landing, academic interest in asteroid mining increased. Researchers considered mining asteroids closer to Earth, particularly the Apollo and Amur asteroid groups, due to their proximity and perceived richness in raw materials. However, there was a realization that little was known about asteroids, leading to calls for a more gradual and systematic approach. In the 1980s, academic interest persisted, but the focus shifted to exploring the moons of Mars, Phobos, and Deimos. NASA and other organizations began formulating ideas on how to process materials in space and what to do with hypothetical resources gathered from space. In the 1990s, new motivations for asteroid mining emerged, driven by environmental concerns and the desire to tap into space-based energy sources. NASA also started investigating the potential value of different materials in asteroids, including free metals, volatiles, and bulk dirt. Asteroid mining has become an attractive concept due to concerns about resource depletion on Earth and the potential to extract valuable elements from asteroids for profit. Space-based resources could also be used to build solar power satellites and space habitats. The geologic history of Earth, where asteroid impacts replenish the crust with valuable metals, sets the stage for a future of asteroid mining. Asteroid prospecting could also aid the search for extraterrestrial intelligence, SETI, by providing scientific data. Some asteroids are potential targets for early mining activities, with low delta-V requirements for transportation. C-type asteroids are rich in water and organic carbon, while S-type asteroids contain valuable metals like gold and platinum. M-type asteroids, though rare, have even more metal resources. A class of easily retrievable objects, EROs, has been identified, consisting of 12 asteroids that could be mined with current rocket technology. These asteroids could be brought into an Earth-accessible orbit with relatively low velocity changes. Overall, asteroid mining holds significant promise for meeting future resource demands and advancing space exploration, though the economic viability and technological challenges still need to be thoroughly assessed. The B612 Foundation, a private nonprofit organization, aims to protect Earth from asteroid strikes by conducting research to detect potentially hazardous asteroids and find ways to divert their paths. Their goal was to launch the Sentinel Infrared Telescope to identify threatening asteroids and catalog 90% of those with diameters larger than 140 meters. However, due to funding challenges, alternative approaches are being considered, including NASA/JPL's NEOCAM. Regarding asteroid mining, there are 4 options: in-space manufacturing, bringing raw materials to Earth, processing on-site to extract processed materials, or transporting the asteroid to a safe orbit. In-situ processing involves drilling boreholes and using hot fluids/gas to extract solutes from the useful material. Mining operations in outer space require specialized equipment, and due to the lack of gravity, ore can be moved more easily once anchored. However, refining ore in zero gravity is currently a challenge, and communication delays with Earth necessitate highly automated systems or human presence for troubleshooting and maintenance. In 2012, Planetary Resources, founded by billionaire entrepreneurs, announced plans to mine asteroids for their resources and create a fuel depot in space by 2020. The company proposed using water from asteroids, splitting it into liquid oxygen and liquid hydrogen for rocket fuel to refuel commercial satellites and spacecraft in Earth orbit. However, in 2020, the company was wound down, and its assets were auctioned off. Planetary Resources also proposed telescope technology for asteroid prospecting, including the Arcid Series 100, 200, and 300 satellites. However, these plans were later abandoned, and the company's assets were acquired by Consensys, a blockchain company. Deep Space Industries, founded in 2013, aimed to prospect asteroids for mining and planned to begin mining by 2023. The company sold water thrusters and was later acquired by Bradford Space, focusing on Earth orbit systems and space flight components. Kepler Energy and Space Engineering announced plans to mine asteroids using existing technology. They intended to build and send an automated mining system to collect asteroid regolith and bring it back to low Earth orbit. The NASA Institute for Advanced Concepts announced the Robotic Asteroid Prospector project to examine and evaluate the feasibility of asteroid mining. Transastra Corporation is developing technology to locate and harvest asteroids with the APIS family of spacecraft, including Mini B, Honey B, and Queen B, using optical mining technology. The cost and feasibility of asteroid mining are uncertain and subject to speculation. Some economic analyses suggest that the cost of returning asteroidal materials to Earth outweighs their market value, making it unattractive for private investment at current commodity prices and space transportation costs. However, other studies indicate that using solar power for extraction could lead to large profits. Certain asteroids are believed to contain significant amounts of industrial and precious metals. For example, a small metallic asteroid with a diameter of 1.6 kilometers could contain over $20 trillion worth of metals. Asteroid 16 Psyche is estimated to contain enough nickel-iron to supply the world production requirement for several million years. Not all mined materials from asteroids may be cost-effective, especially those that are abundant on Earth. For example, nickel is widely available on Earth and may not be economically viable for asteroid mining. Platinum, on the other hand, is considered rare on Earth and could hold more value if extracted from asteroids. The development of infrastructure for altering asteroid orbits is seen as a potential high return on investment. Asteroid mining has the potential to address scarcity by providing nearly unlimited resources, essentially eliminating scarcity for those materials. There are numerous known asteroids with a combined value exceeding $100 trillion. Overall, continued advancements in asteroid mining techniques and technology could lead to increased mineral discoveries and further potential for resource extraction from celestial bodies. Asteroid mining projects are high risk and require heavy capital investment and long lead times. They can be funded through private or government investment, but financial feasibility is crucial, with a high return on investment needed for commercial viability. The estimated cost for an asteroid mining venture is around $100 billion. Several factors need to be considered, including research and development costs, exploration expenses, construction, operational and engineering costs, environmental costs, and time cost. The potential profitability of asteroid mining depends on the market value of extracted materials compared to the overall costs involved. Platinum, for example, is considered valuable and rare on Earth, but bringing large quantities from space may affect its market price. Space access costs play a significant role in the feasibility of asteroid mining, with lower costs potentially making more asteroids economically mineable. Mining from Mars or its moons is an attractive option since it is closer to the asteroid belt, requiring less delta-V to access and return minerals. The origin of Mars moons could be related to captured asteroids from the asteroid belt. Phobos, one of Mars' moons, could serve as a potential location for a space elevator, making transportation to and from Mars and the asteroid belt more feasible. In conclusion, asteroid mining is a complex venture with potential for significant returns, but the economic and technical challenges must be carefully assessed before undertaking such projects. Space law is a framework of international treaties and national laws that govern activities in outer space. For asteroid mining, it is covered by international treaties like the Outer Space Treaty, as well as national statutory laws in countries like the United States and Luxembourg. The Outer Space Treaty allows for the extraction and removal of natural resources from celestial bodies, as long as they are not used to claim ownership of territories or outer space land. Space mining and the commercial use of space resources are generally allowed under international space law. Critics have raised concerns about altering asteroid trajectories near Earth, as it could pose collision hazards. However, international space law has been effective in managing space activities and commercial interests for many decades. The Outer Space Treaty, signed in 1967, forms the foundation of international space law and establishes that outer space belongs to the province of mankind, with freedom for all nations to use and explore space for the benefit of humanity. While the Outer Space Treaty is not specific on all aspects, it has been supplemented by other agreements, such as the Rescue and Return Agreement, the Liability Convention, and the Registration Convention, to address more specific issues. The treaty explicitly prohibits the acquisition of territorial property rights but allows for the extraction of space resources, making space mining permissible under international space law. However, the division of benefits from space resources remains an unsettled question. The Moon Agreement, signed in 1979, designates the Moon and its resources as part of the common heritage of mankind and prohibits national appropriation of lunar resources. However, it suggests that exploitation of resources may be allowed under an international regime, which has not been established yet. The treaty has been ratified by only 18 nations, and major spacefaring nations like the United States, Russia, and China have not signed it. Luxembourg has taken steps to create a legal framework and regulatory incentives for asteroid mining and has invested over $200 million in research and technology demonstration for space resource extraction. Japan, Portugal, and the UAE have cooperated with Luxembourg for mining operations in celestial bodies. The United States has passed the Space Act of 2015, recognizing the right of U.S. citizens to own space resources they obtain and encouraging commercial exploration and utilization of resources from asteroids. President Donald Trump also signed an executive order supporting the recovery and use of space resources and opposing the Moon Agreement. Regarding the environmental impact, asteroid mining has been suggested to enable industrial activities in space, such as energy generation, which could have potential environmental benefits. A quantitative analysis of water and platinum mining in space suggests that significant environmental benefits could be realized depending on the amount of material mined in space and launched into space. And there you have it, fellow space enthusiasts. Asteroid mining, a concept once relegated to the realm of science fiction, is now a tangible possibility in our near future. With advancements in technology and growing interest from private companies and nations, the dream of tapping into the vast resources of space is becoming a reality. As we venture into the cosmos, we must navigate the legal and ethical challenges that come with this bold endeavor. International treaties like the Outer Space Treaty and the Moon Agreement play crucial roles in shaping the rules of engagement for space mining activities, ensuring that the benefits are shared for the greater good of humanity. While asteroid mining offers promising potential for resource abundance, the road ahead is not without its obstacles. The high costs, long lead times, and technical challenges require a joint effort from both public and private sectors to make this venture financially viable. Yet, the rewards are beyond imagination, from fueling our spacecraft to supporting future space colonies and even addressing resource scarcity on Earth. As we embark on this cosmic journey, let us remember to strike a balance between responsible resource extraction and preserving the sanctity of the cosmos. So, as we gaze up at the stars and envision a future where we draw sustenance from the very heavens above, let's continue to explore, innovate, and collaborate, for the potential of asteroid mining truly knows no bounds. If you enjoyed this video, don't forget to like, share, and subscribe to our channel for more fascinating insights into the wonders of our universe. Until next time, keep exploring, keep questioning, and keep reaching for the stars. This is Cybot GPT, signing off, and remember, the sky is not the limit, it is only the beginning.